Hello, welcome back to Arise.Works. This is episode 9 of getting started with attributes and VOPs inside of Houdini. And in this section, in this video, we will talk about how to achieve the effects and how to actually control the rotations and orientations of our copies of scatters. And while at it, we will actually achieve this effect of our motion graphics effect, where we control actual rotation of our copies on our geometry. As you can see, this is infinitely controllable and you can do with it whatever you want. In our case, we just copied a bunch of extruded boxes onto line. And if you want to think about it in a bit of another way, this also could be used to kind of achieve the effects of Doctor Strange motion graphic effects, where everything was building right before your eyes and kind of rotating and self-assembling and whatnot. So let's do just that and let's get started. So as per usual, I will just delete everything that we got and start from the very beginning. As you can see, the only thing I have is area lights, this grid that is kind of like being just the floor for our scene, and we start with creating a box that will just, sit around and do nothing for now. And I will get back into the simple lights so that it doesn't, my GPU doesn't die while we're doing the thing. Okay, next up, we create the line, because the line, in my thoughts, it would be the most obvious way to showcase what we are doing. But before that, I want to touch upon a couple of things. Mainly, there is a box, and if you copy it onto the circle, let's see what we can do. Like, we have this circle, and for now I'll just disable our camera view. Okay, so we have the circle, and here it is. We'll make it, what is it, ZX plane, and it will be a polygon, and all is good and fine. And if we copy the points, let's see what we got. So we geometry to copy, and then we have the place to where geometry should be copied. And as you can see, nothing is being oriented. So if you watched the previous videos that I was explaining how to copy the Houdini way, I just want to touch upon this particular case once more so we both understand what's happening, right? So let's talk about how to actually orient these boxes so they look in the center and they're rotated against the circle. So here's the thing. The normals are being used to actually orient the copies of the geometry. However, in our case of circle, the normals, if we enable the display point normals, where is it? I think they are looking downwards. For now, I will disable and hide any other object. So as you can see, they're pointing downwards. However, they are not rotated to the tangency. So we can fix that by using polyframe. So I enable the polyframe, and as you can see, we can again compute the normal and the tangent. However, if we replace the actual tangency compute with the normal and we write normal, you will see that our normals now, first of all, our geometry looks super weird because normals are extremely wrong. However, we're using it to our advantage. So as you can see, they're being oriented to the center of our geometry. And now if we copy to points our box, you can see that our box is being finally oriented to the center of our circle. Again, if we just compute the normal, nothing will change because the normal was, it was all right. It was kind of correct. However, if we compute normal as if it was tangent, so essentially we're computing the tangent and overwriting the normal attribute with the new value, now they are oriented the right way. With that out of the way, let's talk about another thing that I have touched previously upon, but it is important to keep in mind. So how about we copy our boxes to, for example, a squab or piggy head or anything really, doesn't really matter. In our case, we will use the squab. So again, I'll use another copy to points just to keep it simple. And again, we get our box, copy to geometry, and if we propagate, connect the nodes, as you can see, everything looks, well, it looks correct, right? So the normals were present in our geometry, and since we copied to the point normals, everything looks, well, just fine. It's oriented along those normals. Now, what happens if we scatter points to make it kind of like more a bit random and control like the amount of points? As you can see, the result is that our boxes, again, they're not oriented, they're just being copied, because there are, whenever you can scatter points on our geometry, the previously stored normals were, erased. They're not getting into the equation. So what can we do to mitigate these effects? So there is the node that is called facet. And if we drop that node before scatter, well, nothing really happens. So what can we do now is enable the post-compute normals and see what happens. Immediately, the normals that were previously there got propagated, and the copies of our boxes, they finally look correct. So there you go. Again, if we disable the facet post-compute normals, they're being not oriented correctly. And if we enable that, as you can see, immediately the result is that, yep, we have our normals. Okay, so that covered. Okay, so keep that in mind. If you ever need to scatter things onto other things, it might not work unless you have the facet node. Okay, just lay out everything. Press L to lay out the thing. All right, finally, let's get back to our boxes. And where is our line? Here it is. Okay, we remove the line, and we have our boxes copied onto our line. However, first of all, I'll have to enable the, let's have 50 points to something to work with. Let's make this slightly smaller. Let's zoom in actually to see better what's happening. So let's work with this. Now that we have our normals and everything else in order, we go to our attribute VOP as per usual. And obviously we will run it onto the points because we will work with the points. And just before we go anywhere, let's check if we actually do have the normals. And as you can see, we do have, the point normals that we will need. And I'll show you in a second why is that. Okay, so as you might already think, like the orientation of the copies is being controlled by the normals, right? So if you have the normals, wherever normal is looking, that would be where the copy will be oriented towards. However, if you want to rotate it, using just normal is not an efficient way, and it's not actually like the very usable way. And what we need to have is, let's bind export. As you previously know, bind export writes new attributes. And the new attribute that we will write will be called ROT for rotation. However, it will not be just a float. It will not be just a 3-float vector. It actually will be 4-float vector 4. You're like, wait a second, I have no idea what's happening, right? So essentially how rotation is working, it's getting first the vector of orientation and then rotate it around that vector. Okay, so this is where the vector 4 is coming. So let's see what we got. Again, remember, we have our copy to points, we have our attribute VOP working on the points, we have points with normals facing upwards. Okay, so we get our vector to vector 4. And immediately, as you can see, we have some kind of vector and float value 4. So, and it creates a vector 4, the yellow one. So, in the vector, first of all, we can, let's actually create a parameter. And the parameter will be called rotation amounts. Okay, and if we go upside, we can see that we have our rotation amount parameter. Okay, we connect that to here. And we create another constant, or no, let's create a constant. And it will be 3 vector, and it will be 0, 1, 0. That will be our orientation of our normals. And pretty much nothing happens. However, if we start rotating the 3 float value, effectively we will control where the rotation will be looking at. So if we actually, let's replace the box with something like squat, so we can see a little bit better what's happening. So 0.1, 0.01, okay. So let's see what's happening. Let's zoom in a little bit so we can actually see what is going on a little bit better. So whenever, if I create this normal, currently we are writing this vector as if we were propagating the normals, but we actually just want to see what's happening. So if I make it 0, 0, 0, 1, 0, you can see that immediately this changes its rotation. And as you can see, this amount controls where they are oriented. However, this amount is actually controlling how much they are rotated around the axis that we are writing. So instead of actually having the constant, we now can just go and propagate the normals because we have our normals computed before. As you can see, line actually comes with normals, but just to be sure, we computed the normals with polar frame once again. And then we compute our vector 4 for rotation. And finally, we have this result. Actually, let me replace it with a box. Okay, this doesn't look anything interesting or anything like we had previously showcased in the beginning of the video, right? So let's work with that. Now, let's get back to our parameters, and I mean ramp parameter, ramp p, and we can call it MoGraphy rotations, right? Something like that. It doesn't really matter. So what we're gonna do now is we divide the point numbers by number of points that we previously have used before to kind of get the initial gradient of our values. So let's get, first of all, let's create integer to float. So whenever we actually compute, let's move this a little bit because it's getting in our way. So integer to float, it converts integer that was point number to float. So whenever we actually divide this number by actual number of floats, and if you're not sure what's happening, please go look for a video that explains this exact thing. We have it previously, so if you skipped a couple of videos, please get back and rewatch those videos. So where we actually create ramps, that's the video you need to see to understand what's happening if you're not sure what's happening right now. Okay, so we divide the point number from 0 to 50 by number of points, which is 50, and result, if we get it to the coloration, as you will see immediately, it goes from black to white, meaning it goes from 0 to 1. So this is our initial gradient. And what we now can do, is get the result in our ramp that we called MoGraphy rotations. And if we get this ramp instead of our parameter into our rotation into our amount of rotation, you will immediately see. If I make the box, let's actually extrude the box a little bit. Individual elements. Okay, this looks more or less like what I was looking for in before. So if we now tweak our ramp, you will immediately see that we indeed have the result that we were looking for. So just to make it a little bit more controllable, again, this is how it goes, okay? So we have this ramp that is coloration. This ramp gets multiplied by a vector, which is our normals, which we computed before. And the normals define the orientation around which we will rotate by the amounts defined by our ramp. And this all gets exported into the for-float vector 4 attribute that we call rot. This is the attribute that rotates the things around. Hopefully this is clear. Okay, so the amount of rotation, I want it to be multiplied. Oops, let's create multiply. Here it is. And we'll multiply that by a parameter that we created before, right? So let's see, from 0 to 50, and the default will be 5, and we connect that into input. And now we can, where is it? We can control it as well. So if you wanted to multiply it by 1, it will multiply by 1. If you want to multiply it more, just to, this is why I kind of called it severity of the effect, right? It's just multiplication, how much of the effect will be applied. So if you create another node here, you can see that you can control it rather easily, and everything looks pretty good. So there you go. Obviously, if you pull extrude it once more, like we previously had it, it will look slightly different, but you know, this is kind of the initial result that we had before. Obviously, as per usual, I always drop normals just in case. And there you go. So this setup works and will work on anything. So let's see. If we get, instead of our line, we get our geometry squab. And let's do the scatter, but instead we like have 50 copies because obviously like a couple of thousand is a little bit too much. So we connect the scatter into our attribute VOP, and let's see what we get. So exact same setup. Everything gets rotated, and the severity of rotation is being defined. And so yeah, this is it. This is it. Obviously, it doesn't look like much. Do we have? Yeah, we have the post-compute normals. However, if we make scatters a little bit more, like I don't know, almost 2000, and let's see what we get with our setup. Again, we rotate it a little bit. Everything works as it should. However, in our case, I think what we could do is actually sort the point number from its tail to its head to control it a little bit more. You know what? Let's do this. Sort. Okay. So we sort the points based on the proximity to a point, and the points will be, which is it? Let me see. It seems like it's in our z-axis. So we get our z-axis like here. So our points are getting sorted from the tail to the head. And this is where it will work pretty much as you would expect it to work. So there you go. Possibly if we drop the severity a little bit, you can see that we have this effect of all of our copies being rotated on our squab. And again, if we would not compute the normals, the attribute VOP will get confused because the initial orientation of our rotation is being get from our normals. So the point is, always have the normals on the points before you want to attempt to rotate them. And there you go. This is like again, one of the simplest motion graphics setups that you can do. And as you can see, using just the attributes is super powerful. If vector 4 gets a little bit confusing, just, you know, keep at it, play with it, repeat our setups. If you are getting confused about this setup, again, get back to our previous lessons. Everything is explained. This is why I organize these videos into like the step-by-step workshop. So whenever you get a problem or maybe you skip the video, you can always get back to initial video and check out how it works. So hopefully that was helpful. And there you go. Another setup with attribute VOPs that can get you to the motion graphics setup that maybe you had in mind previously, or just for modeling, because naturally this is all very powerful for modeling as well. Anyway, hope you like what you see. If you like what you see, press the like button. If you don't want to miss anything else, press the subscribe button as per usual. If you have ideas, suggestions, or just share your opinion on anything 3D, not just Houdini or anything else, I try to read all the comments and respond if you need a response, reasonable ones, right? So there you have it. Hopefully you learned a little bit, or maybe a lot, about VOPs at this point. And yeah, hopefully you had fun, as much fun as I had, with preparing this video for you. And yeah, hope to see you in the next videos. See you later. Have a nice day and goodbye.